Alright, the last thing we're doing in chapter 11 is trying to basically go backwards from what we've been doing. The whole time in chapter 11, the biggest thing we've done is we're given a function, a relation, an equation with two variables, and we want solutions, we want inputs and outputs. We made a table of values to get those. Now what we're doing is we're going to be given the table of values. We want to go back and figure out what function did this table of values come from. And so one way to do that, of course, would just be to guess and check. You know, basically, all of our functions that we've talked about look something like y equals, you know, some number times x. Sometimes that was 1, so we didn't actually write a number there. Other times it was, you know, a different number. Plus or minus a different number. So these two numbers were always given to us. So basically, what we're trying to do now is, from this table of values, figure out what these are. Now, one way to do that would be guess and check. Okay, what could I multiply 1 by to get 7? Well, I can multiply it by 7. Okay, well, if I do that, 1 times 7 is 7, so I wouldn't need to add or subtract anything. So it would just be 7 times x. Well, what if I plug in 2 in then? 7 times 2 gives me 14. No, that doesn't work. Okay, well, then I can multiply 1 by 6 and add 1. 1 times 6 plus 1 would be 7. Or what if I plugged in a 2? 2 times 6 is 12, plus 1 is 13. No, that doesn't work. And so you can see there's a lot of different ways I can multiply 1 by something and then add or subtract to get 7. So guessing and checking could take a long time to actually figure it out so that it works for all 4 of these solutions. So we want a way we could do this without just guessing and checking. Well, I'm actually going to call these numbers. The first one I'm going to call m, looking for some number m that goes in front of x. And then we're looking for some number b that goes after it, add or subtracted. And we're going to start by figuring out what m is. M is going to be equal to the change in y's over the change in x's. So what I mean by that is, if you look at your table of values, the y values, it went up by 2 there, it went up by 2 there, it went up by 2 there. The y values are constantly going up by 2, so that change is 2. The x values were going up by 1 each time. So that's a 1. And so that m, the number that goes in front of x, is just 2 divided by 1, or 2. So what we know now is I'm going to take my x value, multiply it by 2 each time. What I don't know is what do I have to add or subtract to get the correct y value. The way I figure that out is by picking one of these 4 pairs and plugging them in for x and y. Okay? I take these, I plug them into this for the x and the y and see what b is. So if my y is 7 and my x is 1, what I have then is 7 equals 2 times 1 plus b. Now, this should be pretty easy to figure out b then. 2 plus b is 7. B must be 5. And so the equation for this table of values is y equals 2x plus 5. I figured out that 2 first by doing change in y over change in x, and then I figured out the b by plugging in one of my pairs from the table for x and y. What I want to do is make sure that this is the correct equation, correct function, and so I check all of my points. If I plugged in a 2, 2 times 2 would be 4, plus 5 would be 9. Yes, that works. If I plug in a 3, 2 times 3 would be 6, plus 5 would be 11. So yes, that looks good. And if I plug in 4, 2 times 4 would be 8, plus 5 would be 13. Yes, that's 13. Yes, that works. So I know now for sure this is the correct function for that table of values. Let's do one more of these. Do the exact same thing. Now, what you'll notice is on this one, the x's don't go up by the exact same amount every time, and the y's don't go up by the exact same amount any time. That doesn't matter. I can pick any two of them. Let's say I pick these two in the middle. I can pick any two and do my change in y over change in x. So m, 2 to 5, that went up 3. That's my change in y. I'm sorry, put that in the wrong spot. That's my change in x. That needs to go on the bottom. 2 to 5 is 3, but that's my x's. So on the bottom is my change in x. So that's 3. Remember, on top is the change in y's. That went from 2 to 11, so that went up 9. And so m, that number that goes in front of x on this one, is 9 divided by 3, or 3. So I know my equation will look like y equals 3x plus something. So now, to get that something, I pick any of the 4 pairs up here. It doesn't matter which one, they should all work. So let's say I use the last one. And I would have 14 for my y equals 3 times 6 for my x plus b. Now, we all know that 3 times 6 is 18. So my equation is now 14 equals 18 plus b. So if I subtract 18, I will get negative 4 for b. So obviously, I was at 18, I had to get it down to 14, I'd have to go have a negative because I'm going down. So b is negative 4, so the way I write that in the equation now is I just write y equals 3x, and this is a negative 4 over here, because b came out negative, I'll just write 3x minus 4. So if b comes out positive, like the first one did, then we write a plus, whatever b is. If b comes out negative, like the second one did, then we just write a minus that number. And this would be my equation. And again, I would go back and check it with the other 3 pairs. And you can check that on your own to make sure they all work. And then you'll know for sure this is the right equation. That's all you do each time. Change in y over change in x. Figure out that number in front of x. And then plug in one of your pairs in your table of values. It can be any of them. To figure out what the b is, what's being added at the end. That's all you do.